So properties of the sine function. Start with that guy. I'm going to give you all the properties. The properties of the sine function, y equal to sine x. Okay? So, yeah, first one, the domain, and we've touched on some of this already. The domain is the set of all real numbers. Remember, we said you can plug in anything you want, negative infinity to infinity. Okay. And 2. Remember, we said that the range is inclusive of all real numbers in -1 to 1, right? Okay. The sine function is odd as the symmetry of the graph with respect to the origin. Okay. The sine function is periodic. With period 2 pi. So every 2 pi, it resets. It just repeats. It resets. And we've seen that when we were plotting points on the unit circle, right? It just keeps going over the same area over and over again. Doesn't change. The x-intercepts, these happen whenever sine is 0, which is going to be -2 pi, -pi, 0, pi, 2 pi, 3 pi, forever, right? All multiples of pi. Y-intercept is 0. The max value is 1 at x equal to well, I disagree the way that's worded. It should be maximum value 1. Oh yeah, I see what you're saying. Sorry. They just wrote it weird. -3 pi, I should write it a different way. -3 pi over 2, comma, pi over 2, comma, that's so weird. Let me rewrite this real quick. Okay. Pi over 2, 5 pi over 2, 9 pi over 2, all correct. Right. Odd So every time you hit the top of the circle, basically, is when you get that 1. Right? So when your x value is up here, right, on the circle, and then it repeats again. Right? You're going to keep getting 0. Or sorry, you're going to keep getting 1 maximum value on your circle. Same thing for the minimum, but it'll just be on the opposite side. The min value is -1, and that'll happen at the bottom of the circle. It's equal to negative pi over 2, 3 pi over 2, 7 pi over 2, 11 pi over 2, etc. Okay? So those are all the properties for sine that you really need if you were to graph it by hand, which you do not have to. But if they ask for intercepts or domain and range, well, you have it in multiple places now. Cosine function is very similar, so I'm going to, stuff that's the same, I'm going to put in quotes, so we don't have to write so much. Properties of cosine. Y equals cosine x. Okay, so the first one is the same. I'm just going to put a little closer. Same as the sine. Second one, same deal. Third one is different. The cosine function is an even function. With symmetry. Of the graph. Symmetry. Oh, that sounds weird the way they word it. Let's change that. With symmetry with respect to the y-axis, which we should already know, right? Even functions are always symmetric on the y-axis. Okay, and here is the same. X-intercepts are -3 pi over 2, negative pi over 2, pi over 2. I should write slower. There's no reason to rush. -3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. So basically, this will be 0 whenever it's at the top or bottom of the circle. Y-intercept is 1. Okay. Max value of 1 is x equal to -2 pi, 0, 2 pi, 4 pi, 6 pi. So whenever you land on 0 or 2 pi, you're going to get 1. minimum value of -1 will occur when x is equal to -pi, pi, 3 pi, 5 pi. So basically odd multiples of positive and negative pi forever. Those are our properties. So cosine and sine and cosine. Let me give you one more, give you a theorem, and then we can go over these ideas. So if omega is greater than 0, the amplitude and period of y equal to the general function a cosine of omega x and y equal to a sine of omega x are given by the following. So basically, when you have to ask for amplitude, all you got to do is tell them what the a is, the absolute value of that a. That's already attached to your function. So you just write the number. No big deal, right? If they ask you for period, that will be equal, also called t, will be equal to 2 pi divided by the omega that's attached to the x. So whatever's right here. So if the question says, hey, what's the period of this sine function? You got to do this. And we'll do a few. All right.
I'm sorry, that variable where it says period equals what?
T, capital T, and
Okay.
then 2 pi over omega. Usually they'll just say period, but just in case they use capital T, I want to make sure you know what it is, what they're saying. Okay. So that's pretty much all you really need to do these questions. So let's do a couple so you can see what they look like. And you'll see that it's not a big deal. First question. Given y equal to -3 cosine of 3x, what is the amplitude and period? The amplitude should be pretty obvious, right? It's the number that's on the cosine in the front. It has to be absolute value, though. So then you would take 3. And we'll talk about what the heck amplitude means just in case. So amplitude is equal to the absolute value of a, which is the absolute value of -3, which is 3. For this question. Period is equal to 2 pi over omega, which is 2 pi over 3. So this is my answer. Or answers, I guess. Now let's look at the graph itself. You guys have any questions about anything so far before I graph this guy?
On the amplitude, will it always be a positive?
Yeah, you always take the positive. So if it's negative, you put 3. If it's positive, you still put the positive. So no matter what they put in front, you change it to positive. Okay, so here is what it looks like. So amplitude being 3 means how high does it go, right? The highest it ever hits on the range is 3, and -3 is the lowest. So that's what they mean by amplitude. That means how high and how low did it go. Okay. Now the period is how fast did it repeat itself. Let's look at the original, right? The original would look like this. And we said that the original at the that was the second set of bullet points. We said repeats every 2 pi. So if it starts here, it repeats about around here, right? 2 pi. You see how it just starts over forever and ever? This other one has a negative, which remember we said when you have a negative on a function, it inverts the graph, right? So technically, this one is shifted, right? In other words, reflected. Where is that 2 pi? So now it's beginning and end are here. 0 to 2 pi. This one, however, repeats a lot faster, right? Every 2 pi thirds. And that is our period. So every 2 pi thirds, it resets again. See what I'm saying? So the reason this 3 is actually tripling the speed of your cosine function. So it's going so fast that it finishes in 1/3 of the time. In other words, 2 pi thirds of the time. So it goes around the circle a lot faster. And this guy is the standard version. Okay. But graphing it, I think, really helps see what's happening. But on paper, all you have to say, what is the period? What is the amplitude? But I do want you to know what they mean, right? Amplitude is how high and low it goes. Period is how fast it repeats. Okay. Pretty much the big picture for this section. It's not much else. So let's keep looking at some questions.
We can't use Desmos during an exam, right?
Yeah, you can.
Oh, okay.
Yeah, I'm not. Well, usually I would try. What we would do in person is I'd give you the option to check out a graphing calculator, and you would just use that to help you out. But since we're not checking them out, then I'm going to allow Desmos if you want to use it. Remember the original. Here we go. The original, at 0, we have 1. So since it's starting something like this on my picture, I want to say that it's probably a cosine function. So at the end of the day, right, we'll graph it and see if it works out. So I know that this is a standard form for cosine, A being the amplitude and omega being your period. Looking at this question, this picture, what is the amplitude? How high and
Looks
low?
like it's 7.
Yeah. That should be, this should be a little higher. Oops, sorry about that. Can't have 2 different peaks there unless it's a harder question. This is going to be 6 right here.
Oh, okay.
So 7 would be up here. That's my mistake. But you're right, it is 7. I just messed that up. Okay. So amplitude is equal to 7. Now let's think about the period. How long did it take to end up at the starting position?
4 pi.
Yeah, it looks like the period is 4 pi, which means it's a little slow, right? It took two whole circles to finally end its cycle. So the period should be 2 pi over omega, right?
Shouldn't it be 4 pi equals 2 pi over w? Shouldn't it be t equal, or the t is the 4 pi, correct?
Yes. Yes.
So it'd be 4 pi equals 2 pi over w, and you solve for w, or omega.
Yeah, you can do that. I was just thinking doing this. But yeah, that wouldn't be right. Yeah, you're right. It's 2 pi, using our formula from earlier, this would be t. Yeah, so it takes 4. Okay, so then we solve from it. Yeah, that's right. So 2 pi over w. You want to know w. So solve for it. We can do your cross multiplication stuff. You can flip both sides over. Doesn't really matter. I like to flip stuff because when I tell people cross multiply, they think they can do it all the time and they forget when to do that. So it's on the w on top. So I'm going to take the reciprocal of both sides. And at that point, I'm just going to multiply 2 pi on both sides to cancel it, and you're done. Right, so this gets rid of it. This gives me a
1/2.
Yeah. I guess the other way would have been the same deal. Yeah, what I was thinking originally was saying, well, the period looks like it's already 4 pi. It's that distance. I was just going to do this, which would give me the 1/2 anyway. But that's really omega. It's not much. So yeah, I think this notation is better. Sorry, I'm just thinking out loud. Anyway, is there any questions on how to find the omega or the amplitude? Once you have those pieces, you're pretty much done. So that would be 7 cosine of 1/2 x.
Is there a b on this one?
No, those are later.
Oh, okay.
I think that might be 7/7.
On the 4 pi, whenever you put it equals to 2 pi over omega, can I just put divided by 1 on 4 pi and do it that way?
I mean, as long as you solve for w, you can do it however you want. You still got you still get the same thing, right?
Yeah.
Yeah, that's okay.
Okay.
So I recommend that you attempt graphing it before you punch it in, because I want to make sure. Is it the same deal?
For the graph of a sine, does it always go through like the coordinate 0, 0?
Yeah, it should, unless it's been shifted.
Okay.
But yeah, it usually it starts from down here and it starts going upward. But if it's been shifted downward, it would be going upward from somewhere else. But generally, the shape and the starting point is similar. Like, for example, like sine x, see how it starts right there, right? The 0 that you were saying. But if you had a 3 sine x, it's the same, still going through there, still kind of similar shape, still increasing. But it still technically starts there. So unless it has a b on there, it will always start from that point. Okay. But if there is a negative, let's look at the negative reflection. Does that change anything? Still starting from there, but now it's reflected this way. Okay, versus the original. So it will not move from there unless you do something like this. You add the b term that we're going to talk about in a bit. So if you do +2 outside the x, not inside, make sure that's obvious. It's still doing the same thing. It's just not at 0 anymore because this is a vertical shift, right? I just hesitate to say always unless it's true. So, sort of. Okay. Let's take another example. Okay, we're gonna move on to 7-8. 7-7 is pretty much the same stuff. As long as you graph them, you'll be able to answer most of the questions, and you just need to remember that the reciprocals of sine and cosine are secant and cosecant. All right. So 7.8. This is about phase shift. And the part that you don't have to do is the curve fitting, because you have your grapher helping you out. Okay. So the there you go. So the general graphs are going to look like this now. It'll be a little bit more complex. It'll be a sine of omega x minus phi plus a capital B. That'll be your cosine, your sine, and your cosine will be pretty much the same deal. Minus phi. Okay. So remember, this is the B is the vertical shift. It will either go up or down, whatever B is. We've talked about omega, how that affects the, what's it called, the period. And A is still the amplitude, so that hasn't really changed. Phi is the only new thing, which is the phase shift. So we've been talking about vertical shifting. The phi will affect horizontal shifting. So let me just write the new thing here. But remember, amplitude, let me rewrite this part. It's still the absolute value. Period is still T equal to 2 pi W, or omega, sorry. Phase shift, phase shift is still equal to phi, or will be equal to phi over omega. Okay. Just remember that if this guy is negative, or if this one's positive, you gotta use the opposite, okay? Because it's a minus v. I'll show you what I mean with an example in a second. Okay. Y equals 3 sine of pi x plus 4. Okay. I guess this is how to be this time. Minus 5. Okay, so it helps to write down what everything is. Amplitude will be our amplitude. It's just going to be the number in front, right? No big deal. Omega is just pi this time. Phi, this is what I was talking about earlier, is going to be the opposite of this. So with plus, you put a minus. If it's minus, you put a plus. Excuse me. Right? B is equal to -5. Okay. So the questions will ask stuff like this. Find period, amplitude, phase shift, most likely, of this graph. Okay. So we already got A, so no big deal there. T, the period, will be 2 pi over omega, which will be 2 pi over pi, which is equal to 2. So we got 2 answers already. Then phase shift. Phase shift going to be,
You slide it up a little bit.
yeah, there you go, thank you. Phi over omega. So that will be equal to -4 over pi. Then they'll probably ask you to graph it or something on some of these problems, but I'd say just use your grapher. So go ahead and do that. Y equals sine, or 3 sine of pi x minus, or plus 4 minus 5. Okay. Let's take this piece at a time, right? So I'm going to block that out for now. So real quick, go piece by piece. What does all these pieces do? So here's the original, right? We said if we put a 3 in front, it triples the amplitude, right? This has a 3. Now, if we do a -5 outside, we said it's going to shift it, right? -5. So it's shifted down here. So here's the original. This has been scaled by 3, the amplitude, and shifted down by 5. Now, if you put a pi there, it's going to affect the period, right? So now it's cycling faster, pi times faster. And now if I add that 4 inside, it shifts horizontally. Oops, that's a 7. So little by little, we're transforming the original function here into the red one. Okay, that's really the main idea they want you to see in these 3 sections is what does each part do, and then can you graph it? But since you have a calculator that will graph it for you, I just want you to look at it and be able to tell which part of the equation did what. So that's what I want you to know is when you look at something like this, can you see it and say, okay, well, I know what this 3 does, I know what that 5 does, I know what that pi does, etc. That's what I want you to learn from 7.6 through 7.8. If you got that down, then awesome. You're good enough for me.
So if it's +4, it shifts to the left negative, or
Yes.
to the left 4, and if it's -4, it shifts to the right.
That's right.
Okay.
It's kind of like when we had the back in college algebra. You remember something like this? Let's block these guys out.
It's been 15
Yeah.
years since I took college algebra.
So let's say we had a plus. So this is the original, right? So if you were to do a +2 inside, same deal happens for any function. The +2 shifts it to the left horizontally. -2 shifts it to the right. So it's the same stuff for pretty much all functions. It's not just special for trig functions. Okay. The horizontal shifts are what's happening here. Okay. Anyway, I think it's pretty much it. I removed some of the word problems that were in 7.8. I don't think they were necessary. But all of it should just be asking you this type of stuff. Okay. Do you guys have any questions in general or about upcoming stuff?
When is the test? I think you might have spoken about it like a couple of weeks ago.
It's gonna be not tomorrow, next week. So tomorrow is Tuesday. So Wednesday we're gonna review. So I'm just gonna go over as much as I can or answer questions, and then the test will be due. It could be due anytime next week. So today's the 14th. I can leave it open till Sunday or Monday, not of next week, but the following. Okay. So there should be plenty of time. You can take it sooner if you want to. It's up to you. If you want to take it on the last minute, that's cool too. I'm thinking of leaving it open up until 27th, 28th, around there somewhere. I haven't set it up yet, but probably 28th.
Okay, thank you.
Okay.
So if we do the practice exam, it's going to be like similar to the exam.
The practice, where's the practice test? The one is there one in Canvas, or did you mean the one in My Labs?
No, I mean the one on Canvas.
Yes, that one should be similar. I remember now. I'll double check though. I'll double check because I don't want to lie to you guys. Let me see how similar they are. So yeah, well, I'll go ahead. I can just do the review with you on Wednesday, and you can try to do it again on your own until you don't really need notes. Then that's when you're for sure ready. Let's see here. Okay, doesn't look too bad. Let's look at the actual time. And they're pretty similar. So similar, but I think the real one is a little shorter. Yeah.
Will there be a time limit on the exam?
Yes, there will be a time limit. Currently, the time limit is 90 minutes.
And how many questions are on the test?
There are 20. Some are super easy and some take time. Let me see here. Yeah, there's a few that you can do in like less than a minute, and then there's a couple that might take 10 minutes. Yeah, so I'll increase it to 120. I don't think you need it, but just to give you guys a peace of mind there. So 120 minutes to do this test. When you finish the test, you will upload your written work into the next. Right after the test, there should be a section for you to upload this paperwork. Okay.
Are we going to be taking the test on the lockdown browser?
Yes, yeah, and I'm required to use the lockdown browser for, and the math department makes me do that.
Okay, and we can use our graphing calculators if we have one.
If you have one, yeah, you can use that, and I will. If not, I will add a exception for you to use the Desmos grapher.
Okay.
But yeah, graphing calculator is fine. Currently, the due date of the test is 24th, but I'll move it to the 28th before class. Okay. Are there any other questions?
No, sir.
If you have no more questions, then you can head out, and we'll do the review Wednesday. Okay.
Okay, thank you.
Thank you.
Good night.
I
Bye.
do want to ask you something, but it was
Good night, I
unrelated.
guess.
Hello?
I'm sorry.
Oh, I said I was gonna ask you something, but it's like unrelated to like class.